Alright, time for another DraftPhysics.com video presentation. Alright, debate physics also, but just a few people who will engage in any argument regarding any theories at all. Frankly, you can't even get that Bill Gates guy to participate in a comparison. This versus that kind of argument about ideas regarding how anything works. So anyway, this Unzicker's real physics. Yeah, it's a misnomer. He does make these clickbait videos, and apparently that works. I mean, he has gained some popularity. This video's got almost 4,000 views in less than a day, which is pretty good. The up numbers don't make any sense at all. It just flipped to 488. Way over 10%, which doesn't make much sense, so I don't know. It seems like a bit of a racket going on. Very popular videos don't get 10%, just doesn't happen. Anyway, but, the comments are full of whatever. Love this crap. I don't, wow, and it's all just wooey crap. Some idea that there's a variable speed of light, that makes any sense. Somehow that Newton's bucket experiment has something to do with gravity, when not really. It's an argument, again, demonstrating from Newton's perspective that space is relatively absolute. Okay, that there is incidental relativity, but there is a reality to movement in the three-dimensional space. And a spinning object kind of proves the point. It's like anytime you spin something, you have to believe that the whole universe is spinning. Like there's somehow equivalency in the two actions, and there's no equivalency. It's clear that one object is moving more than some other object, and you really can't contrive some excuse that says, well, the whole universe just spun. Too silly. It's not a reasonable alternative explanation where you somehow can make the motions equal from both perspectives, from inside and then looking outside. So it's not even about gravity. So let me just do the bucket thing just for an example, and it doesn't even prove what Newton wants it to prove in terms of absolute, beyond just the common sense argument that, do you really expect me to believe that when I spin something, I twist a rope and I let something spin, that the whole universe is potentially doing the action? Come on. There's no reason to believe that. This is all just about the idea that two things can move, and we can make this silly argument that it's just relative motion, when, that either one of them could really be doing the moving and one of them could be standing still, when, because this can happen. But, again, it's sort of a trivially defeated argument as soon as you spin something. Anything. As soon as anything spins in the universe, it's kind of giving it away that the whole external universe is not counter-spinning. Alright, to make it just look like it's spinning, it's really standing still. No, it really isn't. Alright, so the bucket experiment isn't, I don't know. Like I said, people make something out of something. They never analyze the actual motion, that is more than just implied. So you have just a simple experiment. You're just going to take you use a bottle, and you're just going to spin it, and it has water in it, and the water is making some contact with the surface, and the water will slowly but surely acquire the spin of the bucket. So as the bucket spins, the water in the bucket will start to spin, as it sticks. And so the outside water will spin first, and as it keeps spinning, it's going to cause water to keep spinning. All right, and what's really happening? Well, what's really happening is a piece of the bucket is going to move in a straight line from its perspective, on a very tiny level. The bucket's moving in a straight line. Each piece of bucket is just moving pretty much straight. It's not really moving a curved path. And it's just going to transfer that motion to the water. the water is not going to get motion in a curved path. The water molecule isn't going to know it's supposed to go this way. The water molecule just knows something hit it in a direction, and it's going to move in that direction, okay? And then it can hit another molecule obscurely, okay, that is tangentially, and it can end up going this way, or it could end up going down this way. And so there's going to be some change in that motion, but it's all really just straight line vectors. So all the motion begins with little straight lines, and especially the motion here. So once the motion's in here, there's no piece of water that says, oh, I'm going in a circle. No piece of water is saying, I'm traveling a circular path. The water, just like something in space, like a satellite, thinks, okay, from its perspective, it has one velocity, this straight line. And some external mechanism keeps doing this to it, pushing it, turning it. So from its perspective, it's always a straight line. And you're just changing where the straight line is going by adding another force, all right, and changing the path of the straight line. But it's a bunch of straight lines. So this water here that's gaining motion is all just going in a straight line. It wants to get, it's heading that way, and this piece of water is heading this way, and this piece of water is heading this way, and this piece of water is heading this way. And so that ends up, when you do that over and over and over again, right, they're here and here and here, that ends up being motion in this outward direction, because all of these pieces are trying to go straight lines. All right, so that explains why the water starts drifting towards the outside. And then when it's on the outside, well, what's the obvious problem? Well, the obvious problem is just like in the ocean or some other place. You have this water molecule, it wants to go this way, okay, and it's the surface of the bucket's in the way. So it has a choice, okay. Going down, no way, okay. The fluid is uncompressible. There's more pressure going down, so if it does happen to go down, it's going to be popping back up because the water's not going to accept the pressure increase. So it's just going to pop it back up again and try again. And so going left and right isn't going to help it any. And let's say it already has a direction parallel to the bucket. And so really the only alternative, okay, is that the only place where, let's look at it as if it was evolution. And we've made a modification, and now it's going to be tested over time. Well, the only action that time will test as being successful is up against gravity, because that's less pressure. So the water molecules now, because they're all pushing out, they're going to tend to go up because there's less pressure up than there is down. And that's the simplest answer you can give. Is the water's going to go towards the surface. It's going to create pressure against the surface, and the surface is the only yield is up, because down is more pressure, up is less pressure. It's gravity. So it's going to push up based on how much pressure is created, and obviously the water is going to create in the vessel, the water is going to start swirling, and more water is going to end up over here, which means less water is going to end up here in the middle, because it's basically pushing out. It's all trying to go in straight lines out from the center, and the only place to go that's easier to go is up. And that's the simple solution. So it'll happen in space. It'll happen anywhere you do the experiment, because it's really just about making the water spin. And to make it spin, you're really hitting it with straight arrows. And the straight arrows in a circle, trapped inside of a circle, the straight arrow has no choice but to look like out. There's nowhere to draw the straight arrow, okay, without it heading out of the container. It's automatically going to create pressure out. It's not gravity. It's nothing like gravity. It's not synthetic gravity. It's none of those things. So it can be simply understood. Oh, shit. Always something. Be back. Alright, now we've disposed of the bucket as not being that interesting. The thing about gravity is that what's already been. I mean, this is not that hard to deduce. Okay, so all these people say it's not a real force, it's a bent geodesic, it's all this crap, but the simple truth is that you take any piece of matter and it's going to do something that's exactly like a light bulb in reverse. And the only way you could create a light bulb in reverse, okay, the idea that it's going to have a negative radiation. Okay, there's going to be, instead of light doing exactly the same thing, by the way, so a light bulb does the same inverse square law. Okay, the light spreads in this direction, it spreads in this direction. That's the r squared part. Okay, and the gravity is creating the same thing going in. So if you could make light reverse into a light bulb, it's the same inverse square law, right? So yes, the universe is creating energy, and the energy hits the object, and the simple truth is that whatever happens, there's a little bit more energy goes in than comes out. So the arrows coming out are a little smaller than the arrows going in. You can understand no matter which way they go in, they can go in through there, they can go in all kinds of different directions and ways, hitting just the edge, hitting this, hitting that. Doesn't matter, okay, because it all averages out, and it'll all end up being, the simple truth is that a little bit less energy comes out of the earth than went through the earth into the earth. So it gets hit by more than it produces out as reflections or as momentum that goes through it. Okay, the energy hits the surface, travels through the earth, comes out the other side. All right, or comes out, because it's deflected out some other side. It just doesn't matter. The simple truth is a little bit less comes out than went in. And that's really all you have to figure out to explain gravity, is that there's, as we already know, there's all this force in the universe. There's all this light, and we don't see a ton of it. So another argument related to that is, basically he's going to use the immensity of the universe as an argument that somehow that explains gravity on Earth, which is just ridiculous. The matter in the universe doesn't create any pressure, okay? The universe itself is full of the pressure, okay? The empty space, if I take a cube of empty space, there's a bunch of radiation flying through it. So any cube of empty space I pick, it's got a certain amount of radio waves and light waves, if you want to use waves. It's got some atomic nucleuses and some hydrogen atoms. It's got some different stuff in it, okay, in that block of space, and there's an average amount of that, and that's what the gravitational constant is. Gravitational constant is just telling you that this is the average amount of pressure the universe has in it. So wherever you go in the universe and take a square of this stuff, you tend to get this much pressure. Now, obviously, you go right outside the sun's corona or something, there's going to be a lot more out in there. All right, and the fact is that you're going to move based on that energy coming off the sun. All of a sudden, the sun's gravity isn't going to be enough, and the photons flying off of the sun are going to push you, okay, in spite of the gravity. You're going to get pushed quite a lot. All right. The gravity at the sun's surface is only 80 times what it is on Earth. And clearly, once you get outside the corona, it's a lot less than that, 20 times. Not much stronger than the Earth. All right, anyway, the point I wanted to make is that, so the constant can be understood. There's nothing wrong with constants. That's the other thing. This guy thinks all these constants are arbitrary. They're not arbitrary. It just happens that there's a certain amount of energy in the universe per square meter. And it's either in the form of being locked in matter, or, in terms of holding atoms together, or it's free, in the sense that it's a photon flying through space. It's free energy. It's something moving the speed of light that isn't trapped inside of a bunch of electrons and protons inside of an atom. But it's all pressure, you could argue. And so matter essentially captures pressure. would be a simple way to understand it. And capturing pressure is the same as diminishing the pressure. So the more you could compact the pressure into matter, you could argue the less pressure there is on the outside, because there's more pressure on the inside. And the more distance you create, that is, the more you spread the matter out, the more pressure you leave free, and therefore the more gravity you have, because you have more pressure per square meter average. So yes, gravity can change, but the speed of force can't be changed. All right, so the simple argument I wanted to make was that, when we look, at the universe or the Earth as even a surface being hit by the force of the universe, you can understand a lot of the force we can't see, because frankly, we only have a certain amount of matter to collect it with. And the density, the distance from which we're seeing, is so dense that pieces, so there could be a place, like there's a star here and a star here and a star here. And there's these places that appear to be empty, where no radiation would be coming from that place in space. But you can make the simple argument that we wouldn't be able to know that, because there's not enough density on our surface. So there would always be two things that would come in and end up hitting the same location. And we wouldn't be able to see the nothing here, because something from these other places would always be hitting the spots. We don't have enough resolution. We don't have enough pixels to receive the force with for the amount of force that's actually in the universe. So that's another thing to understand. But you really don't need this idea of the matter creating it. So in some sense, he's arguing that if the other material things in the universe didn't exist, that somehow the Earth wouldn't have gravity. And no, I would make the simple argument that the Earth has gravity because there's force in the universe, not because there's objects that the force bangs into and it gets readmitted by. So you don't need burning suns, for us to have gravity. The energy, if it wasn't in that sun, it would be free in the space. So if it wasn't locked up in the matter, the sun wouldn't be needing to admit it, and there would already be more stuff, more force, available in the universe. So there's two things in the universe. There's force and there's matter. And they're two distinctly different things. This stuff is moving the speed of light. This stuff is dead. This stuff has to be pushed by the force. And when it's pushed by the force, it absorbs a little bit of the force's energy by preventing it from going the speed of light, because when it's pushing an electron, it's not going to be pushing it at the speed of light most of the time. Now, if enough force gets behind an electron, it might go pretty close to the speed of light, and therefore it won't be absorbing. But most of the time, it's not going to go anywhere near the speed of light, so the force will, in fact, be delayed in its progress. It won't get as far as it should have gotten. And that's really visible. But who cares? Yeah, really, who cares? Anyway, so gravity is a real thing, It's being created by the elemental speed of light energy in the universe. And the simple truth is that, more of that stuff goes into a material, an atom, than comes out of the atom. And that's the gravity that's created. So it's a very weak force. You need an awful lot of matter to absorb enough energy for us to, have a real gravitational field to be stuck in. The entire Earth is creating the gravity that I'm falling in. It's coming in from all kinds of directions. All right? And every one of those directions that ends with me, underneath me, is one of the places where this force has been diminished a little tiny bit. But a lot of force diminished a little bit is a lot of absent force. So, there's a real physical thing happening. And so anyway, he says this most fundamental problem of gravity is solved. So, who thinks the most fundamental problem of gravity is what he calls inertia? Which there isn't even such a thing as inertia, whatever inertia is. So inertia is just mass. So I mean, you know, why do we need gravity to solve mass? We really don't understand the difference between a photon and an atom. You know, we don't realize that, yes, one of them is moving the speed of light and has a very discrete way of imposing momentum, and the other one has a very obvious way of imposing momentum. So, I mean, you know, and it has to be moved by a force to have any momentum. It has to have a history somewhere where a force acted on it. It can't have momentum without having, or velocity, without having something hit it. Frankly, it's pretty simple. So we'll play some of this gibberish, you know, and I don't understand. You know, I mean, I really am surprised that it appears that, you know, 9 out of 10 people want a silly explanation. They don't want a simple explanation for any of this physics. They want some wooey bullshit about how time is a dimension and we can go visit it or something. And you know, when the first, you know, the 3 physical dimensions have something really, really solid in common with each other, and nothing else can fit, and that's the right angles. All the dimensions, you draw the lines in the 3 dimensions, and it's all right angles. And there's no way to put another 4th line in there without violating those right angles, without creating some other kind of angle. Kind of meaning there really can't be a 4th dimension. But people don't care. They want to live in Wooville. It's just, you know, I don't get it. I mean, nothing ever appealed to me about religious explanations, wooey, phantasmagorical, you know, wizards and crap. None of that stuff ever appealed to me. Witches, warlocks, you know, all that seemed like just the silliest crap people come up with. You're just like, what is, you know, it's just a little, it's like Superman. I mean, come on, it's just not real. You know, and these people really want to, they really want the universe to be this wooey, fake little ESP weirdo place. I just don't get it. Let's play some of this wooey crap.
The current theories of Newton and even Einstein we have.
I guess I better slow it down. His accent's a little bit accenty. I gotta put that on and try to slow it down. I'll leave it a little faster. So he sort of whispers, but he's either too loud or too soft.
And nonetheless, you might not even have heard of the problem. So it's not of very practical use and will not help you weightlifting, but it touches the very fundamentals.
So it has nothing to do with it, but it's very fundamental, and it gets right to the core of something. It doesn't get to the core of anything. So in the end, he's going to get to some paper written in 1955 that he said had the answer in it somehow. And it has some sort of, again, it's just more Einstein crap. The you know, where they just say something like the speed of light squared, you know, because they just want an arbitrarily huge number. So you just square the speed of light because that's an arbitrarily huge number. And they think everything is somehow focused on the speed of light thing, and like it's the magical hinge pin to the entire universe and its function and da-da-da. And no, it's just the fact that there is a maximum speed that these little bits of force travel through space. It just happens that they have a speed limit. And that's it. It's not miraculous in any way. All the force travels it. It all has the same magnitude. It's all quantizable. So what's the big wooey issue here? There is no issue. Blue light travels just as fast as red light. They all travel the same speed. I mean, it really isn't that confusing.
Of our understanding of reality, that is the...
Yeah, puke. Reality. Okay, so he's going to talk a little bit about the bucket experiment, and again, it really doesn't fit as meaning anything in the sense that, yes, I think Newton's just making a simple enough argument. The bucket's spinning. What's your expectation? Do you really think when I spin the bucket, I actually spun the entire universe? Is that a realistic belief? Of course, it's not realistic. And this relativity idea is nonsense. This isn't a framed universe. There's absolute motion in the universe. We absolutely know that the bucket is moving faster than the water. Then the water and the bucket end up going the same speed. And you end up with an equilibrium created where the water does this. And it does this for very logical reasons.
To lean back and let me explain what the problem is. And
so there's no real explanation of the problem.
And he rotates a bucket filled with water until the friction transfers to the water and makes it a curved surface. And he says, okay.
And again, so why does the surface curve? It curves because it's a bunch of straight line vectors. The water doesn't, no impacts in the universe happen where this is curves into this, and this says, oh, I'm supposed to curve. No, nothing hits something and it curves away. There's no curved motion that isn't a consequence of more than one action. There has to be more than one action for there to be a curve. The single actions that take place, the single interactions between every piece of matter, an electron hits another, it doesn't actually hit the electron, right? It's pushing the force, and the force pushes the electron. But the fact is, there is no curvature, built into anything. It's all straight lines. And if you just think of the straight lines going out radiating, you just think of the straight line on the curve. Here's the curve. Here's the straight line on the curve. Where there are all the straight lines pointing? Oh, that's right, to the outside. Obviously, the pressure is to the outside because all the straight lines go there.
This way we know what rotation is, and if you have a rotating frame, you see the water surface level climbing up the walls, and on the other hand, if you have a flat surface, you know that you are in an unaccelerated rest frames without any forces.
And it's a pretty good argument that the only forces that are acting on you are forces that are acting on the bucket, the water, you, We're all on the earth. We all have common forces hitting us at the same time. We're all being pushed by exactly the same forces. We have contained in us already the same impacts that have us moving now in exactly parallel directions. And for there to be a change, something has to create the change. If something's going to be non-parallel or change, it has to change because of the application of a new force. Jesus.
I don't believe in absolute space. That's a concept that you cannot.
So he's talking about Mach and this Mach's objection. So, Mach has a lot of nutty theories, Einstein at first liked Mach and then didn't like anything he said after at that point, and blah, 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 blah. And so, yes, he's famous for, doing some good work, but the rest of the work, you could argue, sucks. So it's just like Young, even Leibniz. I mean, you could just argue that, once in a while they get it right, but then the other half of the time they get it very wrong. And this argument's really stupid. So, Mach's explanation is, well, if you made the bucket miles thick, then the water would stick to the surfaces. Well, yes, duh. All right, he doesn't even, so in this video, he's going to say Mach is saying the rest of the universe is doing it. That's not what he says right in this text. He says, no one can say how the experiment would turn out if the walls of the vessel increased in thickness and the mass, eventually reaching the thickness of several miles. Well, that's a different statement than saying Jupiter's doing it. Obviously Newton would counter with the simple argument. Of course, if you make the bucket thick enough to create its own gravity, then the water is going to be affected by the new gravitational body you've created. So yes, if you have miles of bucket, that would be like miles of earth, and you're going to change the gravitational potential. So if you dig a hole miles down into the earth, gravity changes.
prove as a matter of principle, and there might be another explanation. Okay, so Mach says Newton's experiment with the rotating water vessel simply tells you that the relative motion of the water with respect to the size of the vessels creates no noticeable centrifugal forces. But
yeah, well, obviously there's no centrifugal force. There's just the velocity you've given the water, and the velocity is a straight line force. You can't give something velocity in a curved path. You can only give it velocity in a straight line. And so the fact that the bucket is forcing the curvature is the reason why the force is pushing against the bucket, because the bucket's interfering with the straight line it wants to travel.
But that such forces are produced by the relative rotation with respect to the Earth and the...
So there's no relative rotation. Again, you'd have to think that the whole Earth was spinning in the inverse direction. It doesn't make any sense. It's a silly theory. And that, if the Earth is spinning, I have to spin the whole universe. It's not a plausible theory that when I spin the bucket, you could argue that, well, maybe the whole universe just spun. No, because that would take an insane amount of energy. And obviously no one provided the insane amount of energy to spin the whole universe. So obviously there's just enough energy to spin the bucket. And the bucket is what has the velocity relative to the universe, relative to space. And that's all Newton was trying to say, is the space and the distance is absolute. And you can see the stuff in it moving and detect how much energy it has based on how fast it's transferring, it's moving a distance.
Other celestial objects. No one can say how the experiment would turn out if the walls of the vessel increased in thickness and mass, eventually reaching a thickness of several miles. And he thought, of course, even more. What's his intention here is that the distant masses out there in the universe.
So he's telling us that's his intention, that he didn't intend to mean just a miles thick bucket, that he intended to say the rest of the universe is controlling gravity on Earth, which it isn't. So another, just bullshit, frankly. The force in the universe is creating gravity. The matter in the universe isn't. So jump ahead a little bit.
That because we know what absolute space is, okay? And Mach says, no, I don't believe that. I would rather believe that
So it's all this rather believe stuff. And again, that's the sad truth is I don't see any good reason to believe it, except people want to believe it, apparently. Because it's not logical, it's not simple, it's not Occam's razor, it's not any of these things. I don't know why people gravitate to this mush.
Distant masses in the universe would create a similar force that makes the water surface curve. Well, I have discussed this recently in a real...
So it wouldn't really create a curve, because if you did force there to be real gravity on the surface of the bucket, the water would not stay in the middle at all, and all the water would end up going to one side of the bucket or to the other side of the bucket. There wouldn't be any water in the middle at all.
Physics talk with Andre Assis, and there's also a very nice visualization of the Newton bucket with Dialect, the YouTube channel. But let's pinpoint the...
So cartoons that never really get to the simple truth that all energy is transferred in straight line vectors, and if you put straight lines inside of that bucket, if you force the motion to be in the form of straight lines, just like orbiting objects that are traveling a straight line path, and the added force is what's causing the bend in the straight line. There's no bend in the velocity. The velocity has no bend in it. It's the added force hitting it that causes it to constantly bend. It's constantly being bent into a circle. It's chasing the curvature of the Earth, and it never catches up, but it's always traveling a straight line from its velocity perspective.
The epistemological problem here. Whether you believe Mach or Newton, never mind, but there is a problem.
So, never mind. There's no problem. Okay, your problem is this isn't a gravity experiment in the first place. It's a motion experiment. So it wouldn't matter whether we did this in empty space or not. You don't need gravity to do the experiment because water still sticks to surfaces. Blah blah blah. You can still cause it to move as a complete object. Yes, it's a little more difficult, but it's still doable because of the adhesion between the molecules. The whole reason why this thing works is because the water molecules tend to stick to each other, so wherever one of them goes, the other ones follow.
Newton's bucket, you can see it as a dynamical experiment that determines what is absolute space. And another dynamical experiment is
yeah, so so you have these experiments that indicate that the motion really can't realistically be understood as the whole universe turning. So the Earth is spinning. It's not, the universe isn't turning. All right. I mean, it's just too silly. So let's get to the next phase of this argument.
See what is at rest, and you can also feel with the dynamic experiments what is at rest. And these two frames, nobody wonders very much about that, these two frames coincide. There's the same. That means we're not observing that the universe is rotating, okay? But here's the problem. There is no reason for that in Newton's theory.
So again, he's saying that Newton needs a reason, and he doesn't. Okay, Newton said, I told you how it works, okay, what it does. Why it does it or how it does it, I don't know. But what does he have to know? Again, it's so simple. It's just doing something as simple as what a light bulb is doing, or a candle flame. It's not doing anything more complicated than that. It's just sending force at the inverse square law. And that's all that we're happening here. Gravity is pushing us by an inverse square law into the Earth. It's just a light bulb in reverse. And so all you have to do is say, well, what could cause that? And the simple solution to that problem is, well, there's energy going in and a little bit less comes out. There, that's gravity. And it's not that complicated when you start thinking about, well, what's in the center of the Earth? Oh, a bunch of molten stuff. What made it molten? Yeah, well, the good answer would be the absorption of energy, that is motion. A bunch of force is busy moving little pieces of matter instead of shooting out of the Earth. And that's the deficit the Earth is in.
Newton would say, okay, that's just coincidence. But as a physicist, you don't want to believe in coincidences.
No, so it's not coincidence. It wouldn't even say the word. The fact that the universe has a fixed composition, that is, it has a certain number. It has a certain number of atoms in it. It has a certain amount of per let's say parsec or whatever, square parsec. It has a certain average amount of matter in it. We don't have to sit there and say, why does it have that much and not 10% more or 10% less? Why would we waste our time thinking there would be anything magical about it? There's nothing magical about it. It's just that happens to be that's the way it turned out. Okay, there was probably in the crude system, whatever it is, the crude mechanism that makes this whatever this stuff is. Yeah, this is how much it's made at this point in time. There's nothing magical about it, and there's nothing we need to explain about it. It's just too silly.
Frames, and even more disconcertingly, even in Einstein's general relativity, there is no explanation.
Yeah, so there's no point. It's not even about Einstein's relativity. It's about his bent geodesic, this silly explanation for gravity that has no energy in it. Because it's conservative in the sense you have to spend as much energy leaving gravity as you gain falling into the gravity. So it's conservative in its local effects. And so therefore they don't have to worry about the fact that they haven't explained where the energy comes from. But clearly you want the explanation. You want a rational explanation, not something that just says, well, gravity makes gravity. And that's what this bent fabric is implying. That somehow gravity is making the fabric bend, and therefore gravity is being made by gravity. I mean, it's an empty, vacuous explanation. I mean, you're using gravity to explain the existence of gravity? That's really lame.
This 1953 paper of the British Egyptian.
So he thinks this, whatever, this 53 paper by some Egyptian guy on the origin of inertia. So it's like saying on the origin of mass. There's no inertia. There's no resistance to motion. You have to give something force to make it move. If you don't give it force, then it doesn't move. If you give it force, it moves. There's no such thing as any inertia. Okay, the only kind of real resistance there is that you can have something attached to a surface, and it ends up having a static friction. That is a molecular friction. And depending on what you're doing, if you have really clean metals, this is a real problem for like in space. If they have really clean metal surfaces and there's no oxidation, they can actually have two things stick to each other, and they really stick like crazy glue, where you can't get it off again because there's no oxidation, there's no pollution of the surface layer. And molecularly, you could take a piece of steel and a piece of steel, and you can touch them to each other, and they'll actually become a weld because there's nothing to get in the way. The atoms can just combine like all the rest of the atoms, and it'll really be stuck. So yeah, in that case, you could argue there's going to be some inertia problem because you can't move it because there's going to be an insane amount of friction. But if you take friction out of the argument, there's no inertia. There's no resistance to motion. There's just the idea that you have to push something for it to go. You have to put gas in the car or it's not going anywhere.
A very simple reasoning at the formula for the gravitational constant, and immediately thought, well, somebody else must have thought about this, and so I looked.
So, there's no need to find a formula for the gravitational constant, because what you're basically, the simplest argument is the gravitational constant is just telling you that volume per square meter in space. So it's just telling you that per square meter of space, any square meter of space, there's a certain amount of energy in there. And that's it. That's the gravitational constant. It's just telling you that, there's an average amount of energy passing through any amount of space per any unit of time. And yes, next to the sun, there's more energy. Further away from all the planets and all the suns and all the whatevers, maybe there's a little bit less. And it all averages out to some constant. It's just not a miraculous number. It's not very meaningful. And so he's going to try to force another derivative of it. Let's derive it through some other mechanism than the simple obvious one, where you have this simple association where a material atom will absorb apparently energy, and a less energy comes out of the atom, creating gravity. So the simple truth is that every little tiny thing I put in space, every little piece of matter, depending on how many electrons and protons it has, its atomic mass, it will consume a certain amount of radiation, in the sense that a little bit less will be coming out of it or reflecting off of it than went into it. And that's the simple point. And that's constant. And the reason why it's a constant is because the electrons and protons are a constant. And they're the things actually being hit by the force. Damn.
He arrived at this result. And I did not really appreciate enough the details and overlooked completely.
So I won't, I'll just jump this looks like simple math here, right? Oh, it's just an integral of all the mass in the universe, okay? And all we do is do this, I don't know, R3, R4, R5. We just keep dividing masses by radiuses, a billion times, and somehow that'll give us an answer. So somehow if we know how much matter there is in the universe, that'll tell us how much force there is in the universe, which is not, there's absolutely no reason to think that'll tell you. because it won't account for all the free force that's already traveling through the empty space. It won't account for all the photons already heading somewhere.
As an integral, it's the same thing as the sum over masses.
So it's all this just weirdo math where he just makes up new crappy symbols, does a lot of this and that, does a lot of, the same old Lorentz transformations, all this crap. It's really just crapomatics. Just make up some bullshit, okay, and then say somehow in the end, look, I derived it. I came up with the same number. No.
Vector potential. So, but as I say, I failed to recognize the significance of all this. And even if I had mentioned the problem, let's say I didn't understand probably the paper. Unless...
oh, that's unfortunate that I wanted to read that. And it disappeared. There, that's the... Oh, it disappeared again, so it doesn't show that frame very long. There, okay. So let's start here. Using Mach's principle, we can predict that the angular velocity of the Earth as deduced from the local dynamic experiment will be the same as the deduced kinematically from the apparent motion of the something stars. This prediction cannot be made in Newton's theory because the something, then no causal connection between the motion of the stars and the existence of the inertial forces of the Earth. Yes, the motion of the stars. So this whole idea that the gravity from the stars is somehow affecting the Earth, which is even nuttier. Okay, so we already know how few photons energy we're getting from the stars. I mean, the amount of wattage coming off of stars and hitting us is minuscule. I mean, that's why it's dark at night, is because it's such a small amount of photons that are coming from those stars. Okay, so not nearly anything, barely. And the gravity's less than that, a lot less. So clearly the effect of the celestial universe is not gravitationally doing anything to the Earth. It's way too far away from all of that matter for the gravity to be affecting the Earth. The photons is another matter. The energy in the universe is another matter. Clearly that energy is hitting the Earth. Clearly we are being bombarded in space by a ton of radiation per meter.
And even if I had mentioned the problem, let's say I didn't understand probably the paper. Unless recently a guy from Bristol approached me saying that he was doing a PhD on Sharma's thesis, and I said, okay, interesting, send your papers, and I had a look at the papers, and still I didn't realize, unless my friend and collaborator, Jan Preuss, who's a co-author of that paper on Mach's principle, he said to me, you got to look at this is really interesting. And now eventually...
So whatever, so some colleague persuaded him to look at it for the 17th time, and he finally said, Eureka, I guess. But again, this is just such mush. W equals c squared, and then we have change, times the change in 1 over c cubed or something. I don't know. It's just gibberish. Garbage is what it is.
Lorentz invariant, so in a way it's a technicality.
So again, look at this math. There's nothing simple in any of this. This is all contrived, wiki-wacky crap. And we got this new symbol of whatever, the wackiness factor, multiplied by how wacky are we going to be.
Of a rotating frame. For example, the first component would be the velocity in 2 directions. The second component would be minus the velocity in 1 direction.
So again, all you have to do to understand the centrifugal forces is to understand the energy is moving in a straight line. And any straight line inside of something spherical hasn't got a choice but to point out.
Direction and the 0 in the 3rd direction, and then you have this potential, and now you try to derive these analogous quantities to the
Mathematician crap. Ew. Ugh, yuck. Look at this. Goes on with all this convoluted math to get to some bullshit where he says, well, if I weigh the whole universe, it weighs the gravitational constant something or other. Yeah, bullshit it does. Times the squared, or the speed of light squared. I mean, I always thought it was quite obvious that when Einstein said times the speed of light squared, that there wasn't any reason he did that except to say it's an incredibly small force. That's all. That's it. I mean, you just want an insanely giant number. 3 million times 3 million. Yeah, that'll get you a really big number.
The gradient, since it's homogeneous everywhere, all this vanishes, and you have just this local component, which is m over r squared. You see the inverse square law popping out here, but on the other side of the equation, you have still the...
And again, the inverse square law has to pop out of anything spherical, anything in 3 dimensions. So if anything travels in a direction, right, then it's using up one of the dimensions in the direction it's going. So if something is going this way, okay, it's used up one of the dimensions. And now it still has these two, and it has these two. It has this dimension it can use, and it has this dimension it can use. It's already using this one. That's the motion. All right. And so all you're saying is yes, as it travels, the things left, they're going to always be spreading, and they're going to spread in those 2 dimensions, which is the distance between them is spreading by the inverse square law, because it's 4 times the area for twice the distance. And anything spherical evenly producing or consuming anything, a paint sprayer is the inverse square law. A paint sprayer, it's doing it. It's shooting the little particles of paint, and they're starting off all in here, and they're spreading at the inverse square law.
Respective distances, that's a gravitational constant, okay? And we know that the coincidence is there as far as orders of magnitude are considered. It's the correct order of magnitude, 6.67 times 10 to the minus 11 cubic meters over second squared kilograms. This is the gravitational constant, and he derives it from this very simple ansatz of this vector potential.
Right. So again, you have to believe that that derivative isn't just contrived crap with all of this contrived math. So again, says that's anywhere coherent, and clearly the gravitational constant is going to be clearly related to the function of everything else in space, because everything else in space has got to behave based on that constant. So clearly there's other ways of deriving it based on the motion of any object in space, essentially because any object in space is going to have to be obedient to the gravitational constant. Its motion is going to be dictated by substantially measuring how its motion changes, or how it moves by another body. It's how you're going to detect its mass, and once you know its mass, you know how much force is going to be affecting it.
A consequence of the relative constancy of the cosmological environment. The most groundbreaking result of Sharma's model is, however, that gravity necessarily exists as a direct result of Mach's principle, that is, of the necessity to define a law of inertia in a wholly relational manner.
So it doesn't mean anything. So, I mean, I'll reread this, but I mean, it's just this most groundbreaking result of Sharma's model, however, is that gravity necessarily exists as a direct result of Mach's principle, which is, Mach's principle is there's a whole bunch of universe. There's no principle. Okay, that is of the necessity to define a law of inertia. So again, I don't even know what is this law of inertia. What is this inertia thing they're talking about? Because there is no definition I've seen of inertia that provides any reason for there to be a law of inertia. It's like saying mass has mass. What are we talking about? What is the inertia part? In a wholly relational manner, in the absence of any absolute physical structures. So obviously I would argue that yes, the force is what's causing the gravity, so you don't need the whole universe could just disappear. All the planets, all the suns, all the galaxies, all the material objects could disappear, and you still have all of that energy in the universe. All right, the mass of the universe is not homogeneously distributed, and who would think that's not true? I mean, we all know that yes, it is. Okay, so that's not even a viable statement. If it wasn't homogeneously distributed, then the universe would be showing an obvious lopsidedness. One side would be getting heavier and heavier and heavier because gravity alone would be contracting that side at a faster rate. The inertial field with something motion in the absence of other forces cannot be homogeneous either. So I don't even know where he's going with that nonsense. I mean, that's just plain nonsense, because it would be observable if there were erratic, or if there were substantially inconsistent pockets of heavy density. That heavy density would be acting like a black hole and start consuming everything.
That's referring to the bucket problem and the two interpretations of, we might see that curved surface. Yeah, in a wholly relational manner, in the absence of any absolute physical.
It seems clear that there's a limit. You know, the more interesting limit in the universe is the limit to how big a gravity well can get. Because obviously there's a limit. If there wasn't a limit, the universe couldn't exist, because everything would be swallowed up by the black holes, right? So there's obviously a limit to how much gravity you can create in an area of space, and before that, whatever the mechanism is, breaks up. So a neutron star, whatever you want to call it, it can't get a bigger than a certain size than its own. It crushes under its own weight, all right, and all that energy just gets released like a supernova. So it seems kind of crazy, to talk about how there's a lack of homogeneous when there's clearly a mechanism in space that's preventing things from becoming gigantic. There's a size limit. So much it's not about the speed limit of the force, because the speed limit of the force is the force isn't limited. It's just the fact that it's all the same. It's exactly the same, and it's all doing exactly the same thing. Okay. But this is a much more interesting limit, is that the limit of the density with which matter can compress, because there obviously is a limit, or there would be, a sun as big as the universe. That kind of thing. A black hole.
Structures. Since the mass of the universe is not homogeneously distributed, the inertial field, which defines motion in the absence of other forces, cannot be homogeneous either. The expression of this necessary inhomogeneity.
So if the density of matter is what's causing the gravitational differential, so the more matter you have in a location, the more intense the differential in the field of force becomes. And obviously there has to be a limit built into the universe. There has to be some mechanism that destroys the capacity of those objects to get any bigger. And, I'd say the simple limit is the same limit that's on, say, the function of the sun, okay? And any body that's nuclear, if there's a point where the pressure is, in fact, just too intense, and everything breaks.
It is the inertial field is simply what gravity is. So, as I said, I think
the inertial field simply is what gravity is. So whatever that means, this necessary inhomogeneity of the inertial field is simply what gravity is. So how bizarre is that, when we know it's such a consistent force? I mean, it's always consistent. It always works. The moon's gravity is exactly under the same constant. It all works the same way. All matter creates the phenomenon of gravity and exactly proportional, which indicates that the gravity isn't coming from inside of it, it's coming from something that all these things in the universe are affected by.
You have to let that sink in a little bit. It's really a bold and beautiful result. And it's a result that properly realizes Mach's principle. Mach had suspected that inertia had.
So he's all full of this. Mach and Dirac, all the wackiest physicists are on his, hit parade list. And he really hates Feynman. And somehow he tolerates Einstein. But yeah, it's hard to figure. But he thinks American physics is where it all went wrong, because somehow American physics tried to turn physics maybe a little bit, they said don't get quite as wacky. And frankly, I'd argue quite as religious, because frankly the real argument is the American Einstein arguing against the very religious, theology, of people who wish to give the universe all kinds of spooky functions, little ghostly functions, spirit functions.
Constant, it's as I have mentioned many times, it's very unsatisfactory from an epistemological point of view that you need to postulate a God-given constant that rules.
So again, he says the gravitational constant G is a function of the mass distribution in the universe, when clearly it's the energy distribution in the universe, not the mass distribution. Mass is not creating gravity in the sense that one mass over here can't cause gravity over here in a body. The force does.
All the universe? No, you want to understand, you want to compute that number, and this is what can be done in Sharma's.
I mean, it's really just so obvious. I just take something and just think of it as photons, and all I'm saying is there's more photons go in than photons come out. I mean, what is so bizarre about such a simple theory? And then you have the added evidence that every single one of the big objects is molten in the center, which is just giving you a clear indication that a bunch of energy is being used, to keep all of that stuff molten.
Model that realizes Mach's principle. Now, it's really, you see, I'm really excited, I'm really enthusiastic about it, but to be fair, to be honest, there are still some problems how to connect this with other known facts. And Sharma also was aware of this, and he had a thesis in which he introduces also a metric. I think that's the correct way.
Yeah, it's a more mathematical crapola, so yes, how fascinating. More convoluted math, blah, 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 blah. So let's see what this little rocket thing will be. That might be interesting. All right. Light deflection. So this is, he's saying that, because Einstein played with the idea of maybe, light can travel at different speeds for some specific purpose. I think all the physicists deal with that a little bit in the idea of what really happens when light goes through a transparency. Does the light really slow down? I mean, does the force itself actually slow down, or is the fact is it's just that it's doing more work? And the fact that it has to do more work is why it takes it more time to get through the light, is because it's actually pushing electrons.
When he considered the...
Oh, I should read that. All right. From the just proved assertion that the speed of light in a gravitational field is a function of position, it is easily deduced from Huygens' principle. So Huygens' principle is absolute wacky bullshit. So I don't know how long Einstein even played with that idea. Because clearly, I mean, his 1905 paper is the one where he's basically already showed that light's not a wave. So it is kind of funny that he would make that argument in 1911. That light rays propagating at right angles to the gravity field must experience curvature. So again, they're not really being curved. They're just being deflected into a new straight line vector. But nothing travels an actual curved path.
11 thought about variable speed of light, and actually variable speed of light was Einstein's first idea when he considered the...
So that's not really true, so this isn't anything Einstein really published, so he's just making that part up. Anyway, so illustration of the equivalency principle. So really the point of the equivalency principle is completely debunked by the recognition that in an elevator your feet are being pushed. When you free fall in gravity, the force that's pushing you is not pushing your head. Okay? It doesn't push down on the top of your head. Okay? It pushes every single bit of your atomic structure, and every single bit of the atomic structure is your electrons and protons, and all of them are exactly the same mass as each other, and so they all move at exactly the same speed. So it's just about the fact that, yes, everything will move in the same speed in the gravitational field because it'll only collect the force based on how many electrons and protons it has. It can only, it's only, and the same is true for the gravity. It can only make gravity if it has electrons and protons that are moved and therefore absorbing the energy that the external field is passing through the object.
Equivalence principle. But let's remember, general relativity is fantastic and describes the results in a very elegant manner.
Silly bullshit. Doesn't do anything. It isn't physics. It isn't a physical explanation.
But it lacks explanatory power in two very important aspects. It does not compute the gravitational constant.
It doesn't compute the gravitational constant. Again, why would it? So that doesn't even make sense. It has no the relativity theory doesn't have any obligation to opine on the subject of gravity. It's not the same theory.
And it does not explain this strange coincidence of our dynamical and visual measurements of what means being at rest. I should mention here also...
So again, he's explaining some sort of dynamical measurement problem. There's no measurement problem. We can measure things at rest, and we can measure things in motion, and we can, take the radar gun and point it at a car. We don't have any problems.
Also Erwin Schrödinger, who also suggested in 1925 that the potential of the entire universe might be the square of the speed of light.
Right, and let's understand that he basically said he wished he had nothing to do with quantum mechanics and its formation because you people made such a screaming mess of it. So I don't think Schrödinger would be on your side, because Schrödinger did really want there to be a rational physical explanation for phenomenon, not a bunch of irrational, mushy relativity horse crap.
Which is Sharma's basic formula. So you see, all this is very nicely interlinked. I've made a playlist about this variable speed of light theories with all...
Yeah, so he's got a bunch of crap videos about crap, and he's all interested in, look at the funny little cartoon, ha 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 ha. And, just terrible. Come on, YouTube.
Holistic view, so to speak. So my philosophy is a little bit like Wittgenstein. If you want to understand something, if you want to solve a problem, go to the place where there is oversight, go to a place where you see the big picture.
So what is the big picture again? A piece of convoluted math to derive a number that doesn't need further explanation. The gravitational constant is just so elemental. It's just telling you that this is the amount of pressure there is, that by any amount of mass I can pick, this number will tell me how much that mass can produce as a change in the field. Not extraordinary at all. It's just basically telling you how much pressure is there in the universe. How many photons are going in. That's the constant. The constant's telling you what the number going in is, and the mass is going to tell you what the number coming out is. Not complicated. So anyway, I really do dislike I forgot his name. Alexander. I did talk to him a couple of years ago or whatever, so we did have a little bit of a conversation. Clearly, both agreeing that much of conventional physics is bullshit. Certainly, all of the accelerator experiments and all of this Higgs boson bullshit and all of that is a bunch of nonsense. But clearly he is doubling down on the wave theory of the universe, the Wu theories, and that's his objection, is that regular physics isn't Wu-y enough. He goes for this antimatter crap, this whatever, all of this ESP particle crap. All right, so enough said and such. Yeah, these numbers are just too silly. 555 thumbs up. Again, 10%. I don't get, it just doesn't happen that way. YouTube does not work that way. So I don't know what they're going to settle into, but there's some kind of shenanigans going on. But who are these people? I just don't know how people could find this at all as an explanation of anything. I mean, this video promised some sort of explanation of gravity. The most fundamental problem of gravity is solved. What did he solve? What did it solve? How did he point out how gravity in any way works? Oh, that's right. He didn't explain any of it. Nothing. Gave you nothing. Absolutely zero in terms of an explanation. Why do things fall into the earth? The simple explanation is because they're pushed by an uneven force. More stuff is coming down from space than is coming up from the earth. Simple explanation. All right, till the next time and such, so forth and whatnot. I just hate this planet. Hate it here. Hate it. Ugh.